The wing is a primary load-carrying structure of an aircraft, designed mainly to produce lift. In addition to lift generation, the wing transfers aerodynamic loads, fuel loads, and engine loads in wing-mounted engine configurations to the fuselage. Structurally, the wing must resist bending, shear, and torsional loads while maintaining its aerodynamic shape under all flight and ground conditions. Primary components of the wing are the main load-carrying structural members responsible for resisting aerodynamic, inertial, fuel, and engine loads. These components carry the majority of bending, shear, and torsional loads generated during flight and ground operations. Failure of any primary wing component can lead to loss of structural integrity and catastrophic failure. Hence, they are designed with high safety margins, fatigue resistance, and damage tolerance requirements. Secondary components of the wing support the primary structure and carry localized or auxiliary loads, but they are not the main load-bearing members. Failure of a secondary component does not immediately result in structural collapse, although it may affect aircraft control, performance, or operability. These components are designed to meet functional and operational requirements rather than primary strength criteria. Primary components. Spars are the main longitudinal structural members of the wing and are the principal load-carrying elements. They run spanwise from the wing root to the wing tip and carry the majority of the bending loads caused by lift and weight. Spars also contribute to resisting shear and torsional loads and provide attachment points for ribs, skin, and sometimes engines and landing gear. Ribs are chordwise structural members that give the wing its aerodynamic shape and maintain the airfoil contour. They transfer aerodynamic loads from the wing skin to the spars and help distribute loads evenly across the wing structure. Ribs also support control surfaces, fuel tanks, and access panels while preventing buckling of the wing skin. The wing skin forms the outer aerodynamic surface of the wing and is a primary structural element in modern aircraft. It carries shear stresses and contributes significantly to torsional stiffness, especially when integrated into a closed wing box. The skin also protects internal components and ensures smooth airflow over the wing. Stringers are longitudinal stiffeners attached to the wing skin and run spanwise along the wing. Their primary function is to resist axial tensile and compressive stresses caused by wing bending and to prevent skin buckling. Stringers improve the overall stiffness and strength of the wing without significantly increasing weight. The wing box is the main structural core of the wing, formed by the front and rear spars, upper and lower wing skins, and stringers. It carries the majority of bending and torsional loads acting on the wing. In many aircraft, the wing box also serves as an integral fuel tank, making it a critical structure for both strength and functionality. Secondary components of wing control surfaces, such as ailerons, flaps, and spoilers, are attached to the wing and are used to control aircraft roll, lift, and drag. Structurally, they carry aerodynamic loads locally and transfer them to the wing through hinges and actuators. Although essential for control, they are considered secondary structures because their failure does not immediately cause structural collapse. Wing-to-fuselage attachments connect the wing structure to the fuselage and transmit loads between them. These attachments are designed to safely transfer lift, fuel weight, engine loads, and maneuver loads into the fuselage structure. They are heavily reinforced and carefully designed to ensure structural continuity and safety. In many aircraft, the wing contains integral fuel tanks formed within the wing box. The fuel tank structure includes sealed skins, spars, and ribs that safely contain fuel while carrying structural loads. These structures must withstand internal fuel pressure, thermal effects, and sloshing loads during flight and maneuvers. Wing tips and fairings are non-primary components used to improve aerodynamic efficiency and reduce drag. Wing tips may include devices such as winglets to reduce induced drag, while fairings cover structural joints and system installations. These components carry minimal structural loads but contribute significantly to performance and efficiency.